Section 2.9 talks about calculus of hyperbolic functions. The key for you as far as later on courses is to remember those two definitions. Basically, that's what you need to know. So when you get to differential equations, linear algebra, engineering courses, you need to remember that the hyperbolic sign pronounced sinh of x is e to the x minus e to the minus x divided by 2, and the hyperbolic cosine, or the cosh of x, is e to the x plus e to the minus x divided by 2. That's all you need to remember. And you need to remember that a derivative of hyperbolic sine is the cosine. A derivative of hyperbolic cosine is the hyperbolic sine. There's no minus. Now, if I really wanted to get into the details, this turns out to have all trigonometric identities of its own, and this section in full pretty much is like a very challenging trig section, but this is all we need to focus on. This is all you're going to need for later on, along with those two. And I'm going to use the definition to really derive what's needed. So if I look at number 378 in our book, it says from the derivative of the hyperbolic, cosine, and sine, find the antiderivative. Well, basically, we're going to use the definition on everything that we need. So if I want to integrate, let's say, the hyperbolic sine of x, well, that would be, by definition, e to the x plus e to the minus x divided by 2 dx. I think it's a minus. It is a minus, yeah. Hyperbolic sine, it's a minus. So basically, we take the 1/2 out, and we are integrating e to the x minus e to the minus x dx. And by definition, that is 1/2. That is simply e to the x. This is e to the x divided by -1. That is 1/2 e to the x plus e to the minus x plus c. And of course, e to the x plus e to the minus x divided by 2 is simply the hyperbolic cosine of x by the definition right there. And if I wanted to use, again, or only thing we need out of this, later on you might be asked to find derivative of those. You use the definition to derive whatever you need, and there are a few limits. Anytime they say what's the limit as x approaches infinity of hyperbolic sine, you would apply the limit on this. Hyperbolic cosine, you would apply the limit on that. Take the derivative of the previous expression to find an expression for the sine of 2x. Well, let's see. I would like to take the derivative of the hyperbolic sine of 2x. By definition, that's the derivative of e to the 2x minus e to the minus 2x divided by 2. So the 1/2 is a constant. I would ignore that, and I would apply the derivative on e to the 2x. That's e to the 2x times 2 minus derivative of e to the negative 2x, e to the negative 2x times negative 2 by the chain rule. And that turns out to be 1/2 2e to the 2x plus 2e to the minus 2x. Now, I know that 2's cancel out, but if I drag this up front and push this inwards, by definition, that is the hyperbolic cosine of 2x. So yes, of course, if I would have had memorized that the derivative of hyperbolic sine is the cosine, then simply the derivative of hyperbolic sine of 2x is the cosine of 2x times 2 by the chain rule. But the definition is what you need to derive whatever is needed, and you have few problems to look at in the homework. And that's all what's needed out of section 2.9.